So, this is lesson 2.6, and we're going to talk about concentration and molarity. We're going to define concentration as the amount of solute dissolved in a certain amount of solvent. And you'll remember from last year or the summer assignment, solute is the stuff we put in, it's the amount you have less of. This is what you have less of, and your solvent is what you have more of. The greater amount of solute you have, the more concentrated the solution is. So, more solute in the same amount of solvent, more concentrated. And in this class, there are different ways to measure concentration. You can do parts per million, you can do something called molality, but we're going to use primarily molarity, which you did last year. Molarity, the symbol is a big M, and we calculate molarity by the number of moles over the volume, and the volume has to be in liters. So if this was a 1 liter solvent, 1 liter solution, this is 1 liter, and we put 1 mole of stuff in here, then the molarity of this would be 1 molar. 1 mole over 1 liter, we say that's 1 molar. So you did this in your summer assignment, but we're going to review. We're going to calculate the molarity of a solution, and I underline my keywords when I read a problem, of a solution made by dissolving 23.4 grams of sodium sulfate in enough water to form 125 milliliters of solution. So since I'm asked to, I always write down first what I'm asked to find. I'm asked to find molarity, so I'm going to write down the formula for that. Molarity equals moles over volume. Then I'm going to look to see what I'm given. Am I given moles? No. However, I am given grams, 23.4 grams of Na2SO4, and whenever I'm given grams, I know I can convert that to moles. So I have a way to find moles. Am I given volume? Yes, I'm given volume. Is it in liters? No, it's in milliliters. So the first thing I'm going to do is convert this 125 milliliters to liters. And you can do that as a proportion, or you could do dimensional analysis. We have, for every 1 liter, we have 1,000 milliliters. So how many, that would equal X liters over 125 milliliters. We'll find out what this X is. I'm going to cross multiply, and I end up with this equation. And it equals 0.125 liters, because my milliliters cancel. So my molarity will be equal to my number of moles over 0.125 liters. And now I'm going to figure out my number of moles from this. So if I have 23.4 grams of sodium sulfate, and I can figure out from the periodic table that for every 1 mole of sodium sulfate, that weighs or has a mass of, you can do it yourself, 142.1 grams. My grams will cancel, and I will find out that this amount of grams is equivalent to 0.165 moles of sodium sulfate. So that's what I'm going to put here. Or I'll just write it here. 0.165 moles over 0.125 liters. So if we calculate this, we'll get our molarity, 0.165 divided by 0.125, and that should give us a molarity of 1.32 big M for molarity. We could also write it as 1.32 moles over liters. Either would be correct, but our concentration is 1.32 moles for every liter that we have. That's what the big M means. So in class on Thursday, you're going to prepare a solution. I'm going to tell you the molarity that it has to be. And this is how you prepare a solution. The first thing you need to do is calculate how much mass of your solute you need. to make that molarity. I can't write now. So in this sample problem, you have it on there, you have to create a 1 molar solution, but you only need 0.250 liters. So we're going to now squish this back down again. Leave that little, oh great, it sticks together. So if we want a 1 molar solution, 1.00 m, and it's going to be 0.12, I have to pause, and it's going to be 0.250 liters, then it's question mark, how many moles do we need to put in there? So I would solve for my moles and find out that the moles, I'm going to multiply these two things. Moles will be equal to 0.250 moles of my copper sulfate, which is what I'm doing here. And now I'm going to convert this to grams because the scale measures grams, not moles. So once again, I'm going to take this, I'm going to multiply by the molar mass. 1 mole of copper sulfate is 159.6 grams. And so if you multiply this out, it's a 5. You find that you need 39.9 grams of the copper sulfate to make your solution. So that's what you're going to mass out. You're going to go to the scale then and mass that out. So we'll write that down as the next step. After you calculate, the second step is to mass it out. Mass out your solute. Your third step would be to put it in a volumetric flask. Put in a volumetric flask. That's what this funny looking thing is called. You see this shape? This is a volumetric flask. It's designed to measure a specific volume. This one that they're using is designed to measure, to hold, designed to hold. Actually, it's called to contain, TC. Things are either designed to contain or to deliver certain amounts of volume. These are designed to contain, and this one is designed to contain only 0.250. So you're going to use ones that are only designed, depending on the size of the solution you want. So you're going to put, as they did, put your stuff carefully into your volumetric flask, and then your next step will be to add a little bit of water. So let's write that down. Fourth step, add a little distilled water. Why distilled? Well, if it's not distilled, you'll be adding other ions to your solution, which would affect the solubility. And once you add that, then the next step, if you can see here, well, they don't really show you, but you'd cover up the top and shake it up to dissolve it. I was actually shaking, but you can't see my hand. And then once you dissolve this in a little bit of water, then you add more water until the line will be whatever volume you're looking for. There's a line on each of these volumetric flasks. You'll fill to the line and then cover up the top and shake again. So first you add a little bit and shake to dissolve, then you have to cover it, then you add water to the line and shake. And that's what you'll be doing on Thursday. You're going to make a solution. I'm going to tell you what concentration I want it to be. So this one that is in this picture is a 1 molar concentration, but it's only 0.25 liters of it. So it only has 0.250 moles for every 0.250 liters. All right, so we're going to continue this in the next video.